Welcome to the last week of our class. I can't believe we're here. So, as promised, this week we are going to focus on our data and APIs. So, we looked at all these other amazing things. We talked about color, we talked about recursion, we talked about natural movement. That was a lot of like math. We talked about sine and cosine and the Perlin noise, the concept of Perlin noise. And then this week we're going to dig deep into how you actually set up a data visualization that is intelligible and ethical, because I think it's important to teach you that in teaching you the skills to create a data visualization, right? You shouldn't be able to wield power unless you know how to use it effectively and safely. And then we're going to spend a large part of our class just talking about how to actually utilize an API. We're going to focus in just on public APIs today. So all of this stuff would be applicable if you wanted to use an API where you need a login and a key. I'll address that later in the lecture as well. But just for the sake of keeping things simple and making sure it's accessible for everyone, we're going to focus in on just public APIs. So, of course, let's get into a review of what we did last time, which is trigonometry and Perlin noise, and then Gestalt psychology. So we're just going to go on a quick little tour of the things that we did before, just because it's really important for the ways that your brain integrates knowledge, and so we want to revisit before we move forward. We talked about in Gestalt psychology how there's a framework and then there are principles. We talked about how each of these things in the framework basically amount to how your brain interprets groupings of objects or representations, anything that you are perceiving in your world. And I don't really have to go through all of these. Again, as I mentioned last time, these are things you don't necessarily need to know the words for, but you need to know the concept behind them. Then all of these things work their way into the grouping principles. The grouping principles are incredibly important and share a lot with art composition. Art composition having come many hundreds of years before Gestalt psychology, which occurred mostly in the late 1800s, early 1900s. But these things kind of wrap their way around each other, right? What you perceive to be beautiful or well grouped has something to do with the way your brain perceives groupings. And we looked at the ways that your brain decides what is a figure and what is a background. We talked about how your brain perceives groupings of objects based on how close they are together, how much they look alike. And then we also talked about this closure, which is the concept that your brain will fill in gaps even if things are missing. And so, as an artist, you can use this to your advantage by maybe not showing all of a figure or showing a figure that's broken up in some way to make your viewer look at it for more or ingest it for longer while still understanding the concept of what you're trying to do. So just adding visual interest to your pieces. The second half of these grouping principles look a lot at the way things move and the way that we interpret movement as a part of a group. This would be great for looking at, say, like a group of dancers. Symmetry is the idea that if two people on opposite sides of the stage jump at the same time, you are going to associate them as a part of the same group. And this does often get used in dance or in motion to tell stories. And then the law of common fate being that everything that's moving in the same direction at the same speed will be interpreted as a part of a group. So, like birds flying in the sky, you see a flock of birds, you associate them with one another because they're all moving in the same direction. We talked about continuity, which, in my opinion, has a lot in common with the law of closure. The idea that something will continue even if it's outside of the field of view. So, the example that we saw there was those two keys that were overlapping, and your brain will assume that the key that is overlapped is still continuous behind the key, even though you don't know for sure. It's just an assumption being made. And then the law of past experience. So the things that you see, you will assume they will happen again. You can definitely exploit all of these principles, and many people do. Magicians, I think most of all, especially utilizing the law of continuity and the law of past experience to play with your perception in a way that is interesting or fun. Then we talked about cosine and sine being a form of regular motion that oscillates between 1 and -1. Of course, sine and cosine are offset because of the concept of trigonometry, like the way the math is made. They're going to be offset by 90 degrees or by pi over 2, depending on whether you're in a radial system or in a degree system. And you see here on our screen how that actually plays out, both from the side of the unit circle looking at the triangle and how that translates itself into the oscillating graph. So we talked about the use of sine and cosine to represent motion in code that likes to go from slow to fast to slow, that is a regular oscillating pattern. So the examples that I gave were like a bird flapping its wings. That is very, very easy to model with a sine or a cosine. Then we talked about Perlin noise, the concept that there's an irregular motion or irregular pattern that still feels natural in some way, so not completely random. This is definitely in contrast to pure random, evenly distributed numbers. Perlin noise likes to cluster together all in one spot. So when you graph it out like we saw, you see gradual movement, oscillatory movement, but movement that is irregular in some way. Some of the examples that I gave for Perlin noise, although they are definitely not inclusive of everything you can do with it, involve walking or eating or some kind of mammalian or animal behavior that is oscillatory but not regular. It's also just really great for making beautiful graphics that feel natural and human designed but are mathematical and generative. Getting into it, straight away, we're going to start talking about data visualization. There are a handful of types of data viz. I have a background in science. That's where I was originally trained. So it's very hard for me not to get super into data visualization. We're going to skim across the top of it. These are some important things I think that you need to know about it before we start doing it. There are 4 types of graph. As with any rule, there are things that break rules, but in general, we're looking at comparison graphs, composition graphs, relational graphs, and distribution graphs. The idea here is that comparison is looking at 2 different values or 2 different systems and comparing them, as the name would suggest. Composition would be a pie graph as a great example, how much of a thing is made up of individual elements. The relational is a little tougher for me even to wrap my head around. The idea is, what is the correlation between 2 things? Like XY graph, if I move my phone from one location to another, do I send more text messages? So what's the relationship between these 2 variables? And then last, the distribution would be a map of any space or even an online space, seeing how people or anything else interacts with that thing. So a great example would be, where are there snowstorms right now in the United States? In data visualization, we got to start with the math. The math being there are dependent and independent variables. In math, it is standard to graph your independent variable on the x-axis and your dependent variable on the y-axis. The idea being, as you move from left to right, you see the change in the dependent variable as the independent variable increases. So the standard example for this, if you ever need help in your brain figuring out which goes on which axis, time is always, always, always the independent variable, and it is always graphed on the x-axis. So think in your head, what axis is time graphed on? Okay, I need to put my independent variable on the x-axis. Of course, there's a third option, which would be the z-axis. So that's moving into the 3rd dimension, at least in theory. When you're graphing something on the z-axis, the way that you would represent something being farther back versus closer to you would be the size of that object. This has to do with linear perspective, so objects that are farther away are perceived as smaller. And that's also true when you're graphing in 3 dimensions. The idea here, of course, being that the z-axis and the x-axis can either be 2 different independent variables, or you could be graphing 2 dependent variables and 1 independent variable on your x-axis. There are lots of ways to think about graphs, but this is the one that works best for my brain. Definitely don't hold me to this. You know, there are many other ways to look at graphing, but if I'm looking to graph something, I'm thinking about how many dimensions I should graph it in, and so I'm going to pass that on to you. When you graph something, you can graph it in as many as 4 dimensions, if you think about time being our 4th dimension. 1-dimensional would be a single valued category over a fixed amount of time. So you don't even have an independent and a dependent variable. Usually you're looking at a single time point, or the time doesn't matter to you at all. So looking at hash marks is a great example of a one-dimensional graph. You're just counting, say, how many pieces of pizza I ate today. Obviously 13. And the time limiter is outside of the graph space today. Therefore, we're not graphing over time, we're graphing at a time. You can combine the independent and dependent variable and then look at things in 2 dimensions. So that's an XY axis situation, just like we saw before. One of my favorite representations that is 2-dimensional is what's called a spider plot or a radial plot. You see that here. So here we're looking at the relationship between different factors over the same scale. So the way that we're comparing these is saying everything is between 10 and 3. That's very small there. But the units here are 10 on the outside and 3 on the inside. And then they're graphing each of the indicators on that radial plane. So even still, this is 2 dimensions because we're looking at the relationship between the identity of the thing or the axis of these many radial axes in relation to other things on the graph. And then last, we have a 3-dimensional plot. So that's looking at 2 variables that are dependent and 1 independent, or 2 independent variables and a single dependent variable. This is a great example of a 3-dimensional graph, even though it's graphed in 2 dimensions. We're looking at composition over time. So we see here the composition of 2 different materials that we're comparing on a time scale, which is why we're looking at it in 3 dimensions. We see 2 dependent variables and a single independent variable. Of course, you can always do that over a time value. So looking at the change of something over time and then using your x-axis potentially for something else. And then that would allow you to go into a 4th dimension of data. And I do have some examples later on, I think. So we're looking at misleading practices in data visualization. We've talked about different key characteristics of any data visualization. And now we're going to kind of switch over into the application side. What are things that people do to mislead using data, and how can you avoid making those mistakes? These are, I would say, like the big 4 things that people do. Of course, there are many more, but if you are auditing yourself on these 4 principles, you're probably doing okay. A really easy mistake to make is area versus radius. The idea being that we perceive changes on the radius scale, or sorry, on the area scale, but people can change the radius to make the differences seem much larger between 2 concepts. So here's an example. I've got on the left-hand side, the quantity is radius, the right-hand side quantity is area. If you look at the numbers here, it says 1 is the smaller dot and 1.5 is the larger dot, but this dot does not look 1.5 times larger because the area scales at square instead of scaling linearly. So the larger differences will be out of proportion perceptually. Whereas when you're looking at them as the area, they seem about right. 1.5 to 1 in an area feels right. So always being aware when you're creating your visualizations to be working as area, not as radius. It's a common mistake that misleads people. Making sure you have the appropriate axis is very important, and something I think sometimes can happen in art on accident because you want to exaggerate the changes. So having an inappropriate axis can be done to increase the amount of contrast between 2 different data points. And frankly, if that's what you're doing for your visualization, that's fine, but you need to be telling your audience what you're doing. So doing a switcheroo on the axis, especially in a visualization where it's a little more arty and you may not be labeling an axis, it is vitally important that you tell people that you are not scaling to 0. So what I mean by that is, for example, here you see they're inverting the y-axis. So we have this, which would be like the appropriate way to draw the graph, or actually, sorry, the one, let me wrap my head around this. So we've got 0 to 10, and then we've got 10 to 0. So we're looking at the negatives below the x-axis. So we're looking at -2, -4, -6, or you could imagine it the other way around. Essentially what they're doing is they're flipping it to the other side of the x-axis, and that makes it look like things are going up when they're going down, or vice versa. So always making sure that you have the appropriate y-axis. The other way that you can mess with the y-axis, as I previously said, would be to bump up and skip 0. So here I could move the first value up to 1, and then we would see this change as being more dramatic than it actually is. So being aware of your scale and being aware that you're either going to 0, or you're disclosing to people that you are not going to 0 on your y-axis. Then we have omitted data. Again, if you are omitting data because you think it makes for a more beautiful visualization and you think it is a more poignant way to make your point, that's okay, as long as you are making that clear to people, the reasoning why you did that and how you actually omitted data. This is really, really gnarly when you're getting into medical science or chemistry, for example. Omitting data can really change the way a scene looks. So say like I sped up and slowed down and sped up and slowed down my car, and I was measuring the mileage that I moved. If I omitted the times that I slowed down, it would look like I was moving at a constant rate the entire time. That wouldn't be an accurate representation of the way I was moving through space. So always asking yourself, am I telling the full story? Do I have all the data? If I'm omitting data or changing my axis, I need to have a real reason why, and I need to be disclosing that to the audience of my work. Last, of course, is correlation versus causation. This is often taught by saying murders and ice cream sales both spike in the summertime. Why does that happen? Drownings and ice cream sales both spike in the summertime. Why does that happen? Is it that ice cream is causing people to drown? And the obvious answer is no. People are spending more time at the pool and also eating more ice cream when the weather is warmer. Those things are not related to each other, but they are related to a third data point. So I think my recommendation here for you as someone who's building data visualizations is to be aware of the tendency to conflate correlation with causation and to not tell your audience the conclusions they should be drawing from your work. So you can create a visualization with a goal in mind, and you can spread that visualization with all of the important contextualizing information, but it is not your job as the person creating the data to draw conclusions for your audience. Unless you have that skill set or that's something you're working on, it's vital to remember that two things that look like they're related may be related because there's some part of the picture that you are not seeing. So always being humble in the way that we make our work. So, oh, great, I have one here. Here's an example of a y-axis that is not scaled to 0, and you can see how much more intense these changes look. It would be vital for you to make clear that this y-axis is not scaled to 0, because it can be very easy for your audience to just assume that that's the case and then completely misunderstand your data. These are some examples of beautiful generative data visualizations. As always, I'm here to show you people doing it right. So here is a graph of minimum wage increases. It was published in May 2020 in Fortune magazine, and they're doing this great three-dimensional data visualization where they are looking at, I believe these are states in the United States, and then they're looking at the change in minimum wage over time. So we're seeing where things are the most sloped, where are we seeing the most changes, and then we're also seeing the places that have the highest minimum wage in general in the year 2020. So I think this is a really lovely plot because it uses color, but it uses the color in a way that even someone who's colorblind would be able to see, because we're only changing one of the aspects of that color, the saturation level. It is also really lovely because they're stacking all of these little slices on top of each other, so we're getting to see an entirely increased level of dimension inside of this plot. And then we have a really well labeled axis, and we have really compelling data. Overall, this is a great visualization, and oftentimes news will be the best place for you to go for your inspiration. So New York Times has really great data visualizations. The Economist has really great data visualizations, and then Fortune, any kind of business mag, often has a good data viz team. The New York Times has a dedicated generative visuals team. So if you're ever looking for inspiration for P5 stuff, check them out. They're really awesome too. This is a piece called Melting Memories by Refik Anadol. He is a generative art genius and is definitely at the top of the field right now. So if you're ever looking for inspiration or even looking to see where things are trickling down from, like you look at Fashion Week to see what's going to happen in fashion in 2 years. So looking at his work is a great way to see kind of where the field might be headed. A lot of his work has to do with collaborative AI generating art. Here, I believe he's looking at some personal data of his and running it through an AI. And this is actually a 3-dimensional sculpture. It's very beautiful. It first was exhibited in 2018. A lot of his work is similar to this, but kind of expanded in concept. So go check him out as well. And then I think this is a really great example because it's so simple. So this is a piece called Appeal. It was created by Richard Thay, and it first debuted in the year 2007. The idea here was the artist created a wall that was completely wallpapered in peel-off stickers and asked people at the museum to remove a sticker and then to place that sticker somewhere else. A lot of the stickers ended up on the walls, but apparently they also ended up all over the city in which this was exhibiting. And this is a type of data visualization, and it's an interactive data visualization, but it requires zero code, and it's very lovely and beautiful. I think some of the things that are really cool about this piece are the ways that humans interact in such an elegant way. You can see the average height of people on this. I also think it's cool. There's a couple here that are like half torn off, like someone was being cheeky. And so I just include this to remind you that your work doesn't have to be technically complex to be artistically compelling. So while Refik Anadol is doing incredible work using generative AIs to make moving sculptures that are exhibiting in galleries, there are also people in this world that are working on the sticker scale. And you can definitely be working on the sticker scale and still be doing things that are artworthy, noteworthy as an artist. So just remember that too in this work. Like, don't let yourself get overwhelmed by the data. Speaking of data, let's start talking about how data is formatted and how we're going to get it into our pieces. So there's 2 ways to get your data, and they're interrelated inside of this interface. First, we're going to talk about JSON files, and then we're going to talk about APIs. This is a JSON file, or a little snippet of one. JSON is JavaScript object notation. JavaScript is an object-oriented language. Hopefully that rings a bell with you, but if it doesn't, JavaScript is an object-oriented language. It's a big part of the structure of the language. It's a big part of its identity. And at its core, what that means is that your code is always structured around these objects. So this is how an object is written inside of JavaScript. And you see here we have an outside level. So these brackets enclose the entire JavaScript object. Then we have a labeled object inside of that encapsulating object. And then inside of that, we see the title and so on and so forth. So we can go deep in. I highlight this part of the object for you so that you can see the fact that an object can be its own encapsulation and have nothing related to it, or it can have lots of other things inside of a list. All of those things are separated with commas. And you want to make sure that any strings inside of a JavaScript object are encapsulated inside of quotation marks. We haven't talked about strings yet. The idea of a string is anything that's text and not numbers should always be inside of quotation marks in your code. So just always making sure that you're putting quotation marks around the strings inside of your JavaScript object. And the really amazing thing about a JavaScript object is that you actually call the values from their names. So if I wanted to get this ID property, I can call the glossary, the title, the gloss div, the gloss list, the gloss entry, and then the ID. So everything is nested inside. Let me show you what I mean. So just a reminder that hitting return is more of a format for you, the human operator, than it is for JavaScript. So here you see I've taken this inner portion of the object and just put them all on one line for the sake of space. So don't get confused. Enters are just there for humans. The computer can't tell the difference as long as you have commas in between your lines. Here I've got an object called cats. And then inside of that object, I've got a category called mine, 2 names for each of these 2 objects, and then attributes that I've assigned to those objects. So if I wanted to call, for example, the age of the cat Fluffy, I would go into my JavaScript code and print cats.mine.fluffy.age. So you see here, I'm going from the top level and then kind of flipping through it like it's a dictionary, cats, mine, fluffy, age. And the answer I'll get would be 8. So a self-check opportunity, if I was going to set cats.mine.sunny equal to the variable of x, and then print out that variable, what would I get? So you can go ahead and pause if you'd like to answer that question on your own. It's going to spit out the entire interior of that object. So this is a great affordance, a great thing to know if you want to see the structure of a JavaScript object that maybe isn't inside of your sketch, but you need to have information about how it's structured. So we'll use this inside of the work that we're doing today. This is something you can practice endlessly. Go Google JavaScript objects and start working your way through them inside of a P5 sketch. Just practicing how to navigate around them is a really good way to get familiar. It's a map, so you need to be experienced with how to use that map in order to be better at how to display that data. I'll show you how to access this and how to display it inside of a P5 sketch during our code demo, but the more practice you get with it, the more familiar you'll be and the better you will be at manipulating data. Another quick note, we won't be covering this inside of our code demo today because we're specifically interested in reading data, but you can write to a JavaScript object from your code and change the value. So if for some reason I wanted to change Fluffy's age, maybe I got it wrong when I was creating the object, I can just do cats.mine.fluffy.age. So we go cats.mine.fluffy.age and then set that equal to 10. And then I'm checking my work here by saying print cats mine fluffy age, and the response will be 10. The same is not true if you are changing the variable that you have set equal to a part of an object. Hopefully this will be obvious, but I just want to make it completely plain for you so that you don't end up confused down the line. For example, I set a variable x equal to cats.mine.sunny, the same as we did in the last. So you'll, in theory, get the spit out, age, favorite food, color. If I change the value of x and print x, I will get the string nonsense. But if I print cats.mine.sunny, I will still get the interior of that object. So if you want to change the object, you have to actually access it in JavaScript object notation, and then you have to insert a new value. So let's talk about APIs. Why do they matter? What are they? How are we going to use them in our code? The internet is built out of computers that are all connected together. At its core, in all of the magic and mystery that is the internet, it is a bunch of connected computers. And technically speaking, if you are the person typing in the URL and accessing the internet, you are a client. And if you're the one passing out the information, you're a server. So anytime you go log into Facebook or Google, you're accessing a server or a bank of servers, and they're serving you that website. One way to connect would be your just straight up browser, but another way to connect is through the use of an API. An API is called an application programming interface. Basically, it's a way for you to use your code to talk to a server without having to intervene beyond running the code. So you get to put in a format that is a URL, essentially, a way that a server wants to communicate with you, and then it will give you an answer. APIs can do a lot of stuff, anything a server can do. Here are some like super snapshotty examples that you might be interested in utilizing. You can look at the state of a system. There's a lot of weather and stock market application programming interfaces. You can manage your bank, or you can buy things with an API. You can post to social media. The Twitter API is a really common and easy to use API. It's easy to create bots, which is why there's so many problems with bots on Twitter. Twitter and Reddit both have very easy APIs to use on the whole. So if you're looking to do social media work, definitely check out those. You can have them do math for you. MATLAB has an API which allows you to say, have the computer solve a function and then send you back the value. And it can also connect you to an artificial intelligence platform, something that's already been trained, but maybe can take the data that you pass it and give you some kind of response. So I've used this before to have the computer send me back a sentiment analysis on a block of text. I was able to send Watson text, and then Watson sent me back the text coded with all of the emotions that are inside of it based on the AI. Before we move on, you can run an API in just about any language that's out there as long as your computer is connected to the server, which either means you need to be locally connected, or more likely you're connected to the internet and the server is connected to the internet. We are just going to focus obviously on JavaScript APIs, but often you'll see in documentation API calls for other languages. So don't lose your mind. JavaScript is just one of the options for accessing an API. And then the idea is that an API will almost always send you back a JSON file. So that's why we talked about JSON, both as a way to just encode data inside of your JavaScript sketch, which is what we're going to visit first. And then after we've kind of familiarized ourselves with the structure of a JSON file and how to access that using our P5 skills, then we'll take it to the next level and start to utilize a JSON file that we get passed back to us from an API call to create a piece of generative art. All right, buckle up, here we go. We are in a blank sketch in P5.js. We're going to leave everything as its default. Our main focus here is going to be on building and utilizing a basic JSON file just to give you the opportunity to play around and understand how JSON files work. Just like we did when we created our image to load into our sketch, we're going to open up our files window in P5.js. And then I am going to actually create a JSON file, and we're going to go for just the same object, the basic object that we had in our lecture. So I'm going to call it cats.json, and then we'll fill it in with the data. The data that we had in our sketch was just, or our lecture was just an object that is called cats. And then inside of that object, we have mine, and then the names of the cats. And you'll notice as I'm typing this out here that I am again putting all of my strings in quotation marks, and all of my numbers can stay as numeric values. So always in your code, you want to make sure you're putting your strings inside of quotation marks, because that's how it likes to handle them. And if you're ever looking for ways to manipulate strings, that's how you would Google it. So that's like code talk for text, basically. And then I'm just going to copy paste this and then change the variables. Okay, so here you see that I've got brackets that are all paired with one another. This bracket is the bracket for the cat named Sunny. This bracket is all of the information for the cat named Sunny. Every JavaScript object should always have everything separated out. One thing I'm noticing here in doing a little audit of our JavaScript object is that our commas need to be on the outside of those brackets. So what we're doing is we're separating the entire object of Fluffy from the entire object of Sunny using those commas. It looks like I'm getting an error. I wonder what it is. Let me audit this really quickly. What do you say? Oh, okay. Should be fine. Let's just pop this up on a line. Hopefully that will help. Yeah, all should be well. Anyway, let's make sure this works because perhaps there's something I am missing. Oh, I understand what I've got wrong here. Hopefully some of you saw before I did. These are, Sunny and Fluffy are two objects inside of the mine. So instead of adding an end bracket here, we want to make sure we have our end bracket here. So this level of object is encapsulated entirely in those two brackets, whereas before I was separating them. Hope that makes sense to you. So now we've got our JSON object, it's structured. I'm going to save my sketch, and then I'm going to jump back over into my actual sketch file, my sketch.js file. And just because my screen is a little small, I'm going to minimize that to the side. So the first thing we need to do is load our JSON file. We do that the exact same way we loaded the image file. It's just going to be a slightly different command. So it will be function preload. And then we're going to say load, so we're going to say load JSON, and then our file name, which is cats.json, but we need to make it equal to a variable. So I'm going to call that variable cats, and then I have to initialize the variable. So let cats, and then now we have a variable cats that should be equal to the JSON file that we just created. Got to make sure that file name is in quotation marks. And I am going to just print it right now to make sure from a debugging perspective that we have what we think we should have. So we're going to print the variable cats in our setup. And then let me refresh my sketch. Looks like we do. So we have an object. It looks exactly the same as the one that we made before. And you can look down in your console and see the actual structure of the object and confirm that it's all actually there. So you can just audit yourself really quickly. If you run into any trouble at this step, just go back and make sure that your object exactly matches mine. It's very possible that, like, say you're missing a comma, or another really common thing that happens is there are two different formats of quotation marks. There's one that's used in code, and there's one that's used in like Microsoft Office or something like that. And the ones in Microsoft Office have curly ends, and the ones inside of this sketch, I'll even change these here so you can see them. You see that these guys have like straight ends. You want to make sure when you're using stuff in your code to denote strings that you're always using those ones that have straight lines on them. So if you have any trouble loading in your JSON file, or it's not reading the way you think it should, that would be a good debugging step. Okay. The next thing I want to do is just print out some of those words in a format on our screen. And we're going to do that by actually looping through the variables in our JSON object. So accessing things in JSON, you can do what we did before. So we'll do like print cats dot mine dot fluffy dot age. And then now you'll see in my console, Fluffy's age, which is 8, will appear. But especially because in our next part of our code demo, we're going to be working with some JavaScript objects that you maybe don't know exactly what they look like, or they're super long, so you can't do all of that manually. We're going to do it in a loop, sort of similar to the way that we've used loops in the past. So the first thing that I'm going to do is create this thing that loops through our object. And be on your toes if you've never used something like this before. Oh, we're having errors. That's okay, we'll keep going. So if you've never used JavaScript objects before, be on your toes right now, because this is something that will be new and maybe like a little bit uncanny because it's familiar, but it's not the same. So you see here, I've created var k. I could make it I, which would be standard practice. So I'm creating a variable that's a counter variable that's going to look through our entire object on the mine level. So because I can look at this object and see there's nothing at that level except for the word mine, I'm going to zoom us in just a little bit farther and focus on looping through that part of the object. Next, I am going to print, so we can debug as always, cats.mine with a bracket and then the letter I. So what we're doing here is looking at the console to make sure that our loop is spitting out both of the objects inside of that object. So what we're hoping is that we'll see Fluffy and Sunny, the interior of Fluffy and Sunny, get spit out into our log. So let me just refresh this. You'll notice I have auto refresh off right now. Later, when we are inside of our big sketch that has to do with USGS, it can be a bit of like a bandwidth pull to be running it every single time. So when I'm working with big pieces of data, I usually keep my auto refresh off. With this, you could definitely leave it on. I just have it off for later. So look what we got. We got 2 objects, because it's printing each time it loops, that are the interior of our 2 cats. So we're getting exactly what we expected to get. Now I might want to put that inside of our sketch in some way. So we're going to write it out in our text. I'm thinking that we will create text that says how many cats that we have. And the way that you would write text would be using this text command. We're going to set a variable equal to a string. So right now we'll just test it out. And then you should see over on the right-hand side, we have the word test. So far, so good, I hope. Next, we are going to actually set that how many equal to the size of our cats.mine object. And the way that we'll do that is by adding a variable called size. And then adding 1 to the value of size every time we go through our loop. So it's vital here that you set size equal to 0 before you start. Otherwise, you will run into an error. So if you're running into an error where size is not defined, make sure you define it before you start adding to it. You can't add value to something that doesn't have value. Next, we're going to add using the increment command. So we're just adding the number 1 to size every single time that we loop. And then the last thing I'm going to do is just replace this how many with the variable size so we can confirm that we got what we expected to get. And here we see the number 2. So we know that there are 2 cats inside of that array. All is well. The next thing we're going to do, just because it will make our sketch look prettier and maybe be more intelligible, is give that number a unit. So instead of it just being a number floating out in space in our sketch, we want to make sure it has some context. And the way I'm going to contextualize that is by utilizing strings and the ability to concatenate them. So we're going to say, how many cats do I own? And then we're going to add size to that value. So now we should get how many cats do I own plus the number 2. And there we go. One thing you'll notice here is that there's not a space after a question mark there, and that's because we didn't add one. So whenever you're concatenating your strings, it's important to remember that computers can't assume that there are spaces, and we want to make sure that those spaces are added in manually. Okay, here we are, we have a space. How many cats do I own? 2. Just for my own peace of mind, as you should always label your data, I'm going to say 2 cats. And you notice I put a space at the beginning of cats because otherwise there won't be a space there. Here we've got, I think this is awesome the way that it is. I am going to show you how to add one more piece of data, which would be the ages of the cats. And it's going to require us to use a little bit of flexibility and maybe some creative thinking in the way that we put our data into our sketch. I'm also going to change the text size really quickly just for aesthetic purposes. This is an art class after all. We got to be beautiful. Okay, So next I'm really interested in knowing how old each of the cats are. So we're gonna create a variable called how old. And then we need to figure out what we're gonna add to that to create our response. So you cannot just grab those values unless you know the length. In the interest of efficiency, we're gonna do this the right way. And the right way to do this would be using an array. So this is our first introduction to the concept of arrays. We're actually not gonna revisit this at all through the rest of our lecture, but it is a really key piece of information if you're not familiar with them. Arrays are usually utilized to do the work of an object, but in a smaller way that you can actually say the position of that array. So for example, if I was to list like 1, 2, 3, 4, 5, then I can actually call that value and print it out inside of our console like this. Let's say I'll do print, and then we'll do ages at the position 0, because the computer always counts from 0, and then I will get the number 1. Oh, wow, it's a little bit messy down there. Here, let me clean that up for you. I'll get the value 1 because that's the first position inside of the ages array. We are going to fill the ages array with information from our JavaScript object. And we'll do that by pushing to the array each time we loop through our object. And we're going to do ages, which is a reference to that array, dot push, which is telling the computer to add a value to the end of that array each and every time we go through the loop. And then we're going to push the value cats.mine I dot age. So now what we're telling the computer is every time you go through the object, I want you to add the value of the age at that position to the end of our ages array. Let's just check and see what our output is by printing the entire ages array. So I'm going to do print and then ages. We should see the value of that array come up in our console. So now I hope you're understanding where I'm coming from. The ages of our cats inside of our cats.json file are 8 and 4. And then we went ahead and pushed those values using that loop to our array. So let me jump back over. Here we are adding that value to the end of our array each time we go through the loop. So we could simply add ages to that how old value and then write that text inside of our sketch. So we'll say how old, and then we're saying it's at the X position of 30 because we want them to be aligned. And then the Y position, I'm going to make 100 so that they're not overlapping with each other. Now we see how old are they? 8 and 4. But because we're going conversational on this piece, I'm going to make it conversational. The way I'll do that is just simply by doing ages at position 0, and then the word and with a space on either side, and then ages position 1, and then you always label your data, so we'll say years old. So now we should see when I refresh my sketch, the question how old are they, and then the answer 8 and 4 years old. So let's check it and make sure it worked. Here we go. So I'm hoping that this will give you the ability to understand the basics of how to move your way through a JavaScript object using code. And it will also give you a familiarity with the structure of a JavaScript object. Again, the best way to use your debugging skills is just printing each and every time you feel like you're lost or you don't know what your response is, verifying in your console before you move forward so that you make sure you're getting what you need to get. So that's the basics of a JavaScript object. Let's move on to our next sketch. I'm just going to create a new one here. In our next example, we're going to start using an API. Using an API is, again, our way of calling into the internet to access a server and then getting back a response. Oftentimes you need a login to get to an API, That's because they want to know what you're using the data for, how often you're using the data, and how much data you're using, because they'll often charge you after a certain level. We are just working with public APIs inside of this one, so we don't need any keys. This API that we're going to use is called catasaservice.com. And what it does is it sends you, I don't know what I'm doing here. It sends you a random image file based on some parameters that you put into that API. So let's start by just creating a variable called image URL. And that will be how we access the API. And then the basic API call for this service is catasaservice.com/cat. And this call will send back an image. So in just the same way that we could use this to load in a JSON file, just like we did before, we're going to use this to load in a image file instead. And in fact, as is always the case, we want to do this all in preload. Preload just means we're running it before our sketch starts, whereas setup happens on the load of the image, on the load of the canvas. And so we always want to make sure we are accessing the API and getting the information back before we start drawing anything. Okay, so we've got our image URL. Then I'm going to create a variable for our image like we always do. So let image equals load image. Hopefully this is feeling familiar both from last week and from loading the JavaScript object that we just loaded. And then here we're just going to load image URL. Since you'll remember, load image can work on a local file and it can also work on a file you grab from the internet. And then last but not least, we want to make sure that we actually have the image that we think we got. So let's do image, which is the call in P5.js to get our image, the name of our image variable, and then the position 0, 0. And then hopefully when we load this, we'll get a random picture of a cat. I see some problems with this. The main one being that our cat is not fully fitting inside of our screen. And that's because his dimensions don't match the dimensions of our canvas. And this is where we can start getting into the API call information. So every API call is structured differently. This one happens to be structured like this. So we're going to do question mark after cat. That's how we delineate our first value in the API call. And then we're going to say width, which is the width of the image we received back. And then because our canvas is size 400, we're going to size our image to that same dimension. So let's see what we get now. Cool. Really cool. We get this cute little cat and he is fitting inside of our canvas. Awesome. Unfortunately, the way this API works is that it will serve us the same image no matter what, based on our API call. So no matter how many times I run catasaservice.com/cat, I always get that same picture of that tabby cat. I don't want that. So I'm gonna do two little pieces of like clever code to get us some different cats. Just like with our string concatenating inside of that JavaScript object work we just did, we can do the same thing to make our API calls. So I'm going to create a variable called random size. And we are going to add that into our API call. So now what we're doing is saying, I want this image to be sized however randomly we put in for this variable, and then send me back whatever you get based on that random number. I don't want these images to be stretched out too much, so we're going to stay kind of in the neighborhood of 400 pixels, but we'll still get a lot more randomness, more generativeness, just by adding this random value. And we're going to do random from 350 to 600 because it's all still very much in the neighborhood of our 400 pixel wide canvas, not super huge, not super small, so we're not going to get any weird artifacts from moving that image size. Oh, so cute. Now we've got this cute little piece of cat sushi, but you see here, unfortunately, our cat sushi does not fit inside of our canvas. The last thing we're going to do to add a little bit more complexity to this API call is adding the value for type and then square. All of this stuff comes straight from the documentation for this API, and that's where you'll have to go anytime you want to use an API. So I kind of already worked out the kinks on this one. I'm showing you directly how to use it, but always this just comes down to reading the documentation and understanding what the API calls are actually looking for. So now what I'm asking for is I want our API to send us back a square image that is randomly sized. And because I know that image is square, I can utilize our image command in P5.js to make that image fit our canvas every single time. So we're going to make it at the widest point as wide as the width of our canvas, and at the tallest point as tall as the height of our canvas. So now no matter what happens, our P5.js sketch is going to do the math to make those images the same size as our canvas. So let's give it a try. Wow, what a majestic cat. And now you can run this a bunch of times, and no matter what happens, you'll get a different image of a cat. Unless, of course, you run it so many times that you see every one of these random numbers between 350 pixels and 600 pixels. But that should get you to the understanding of how to utilize an API call, how to structure an API call inside of your code, and then how to start using that to do some generative work in our code. The last thing we're going to do is pretty advanced, so buckle up. We're going to use the USGS API to create a map of all of the earthquakes that have happened in the last month. So we're going to start basic. We're going to start basic with just an API call to the USGS service. So you'll remember the first thing we need to do is make it preload. And then we will create a variable that holds our URL. So let URL. The URL is our API call. So I'm going to type this all out for you. Again, this comes straight from the documentation for this API. So if you're ever curious about this or you're looking to do an application with an API, you always want to consult the documents. FDS, NWS. And now we're getting into the actual API part of the API call. The first part is just like all the garbage that we need to get to there. And now what we're going to tell it is we want our file formatted in what they call GeoJSON. And you can get a return from this specific API in a couple of different file formats, which is why we have to specify. And then we're going to say start time for our returned call, just to keep our data small. And then we're going to add a variable start date to this call. So of course I need to initialize that variable. You can always change this variable. I'm going to set it to a month ago from the time that I'm recording this. So I pre-record them. And then we're going to go to 0914. Which is like a week ago, 2 weeks ago for me right now. And then what's going to happen is it will fill this date into the API call, just like we did with the cats, and it will return all of the data for all of the earthquakes that USGS has collected over that amount of time. And this is just, again, part of their documentation. That's the date format they ask for us to use. Last, we're going to load our JSON, and you'll remember we need to give that a variable name as well. So we're going to call it earthquakes. And then we're going to say earthquakes equals load JSON and then URL. So here we have an API call that's structured based on a variable we've inputted, and we are returning that API call in the form of a JSON file. If I do this, I should get nothing, just gray background like we always get. See, you'll notice here it's taking a while to load, which is why we're preloading everything, and also why we're keeping that file small using that start date. In order to verify that I have the file that I want to have and it looks the way I want it to look, I am going to print that file. So we're going to print the entire earthquakes JSON file. So now you understand what I meant when I said if you're debugging your JSON objects, you want to make sure that you are just printing them out and then looking at them manually so you can get an idea for the structure of them. And as I open up this file, I see there are a couple of subsections here. We've got metadata, which is information about the actual call. We have features, which is information about all of the earthquakes. Wow, it's a big file, so it's taking a while to open. And then each of these is an earthquake. So we can see what the magnitude of that earthquake was. They have their own time coding here. You can get some typed out information of where that was located. And then inside of the geometry, we get to see the type of earthquake, if you're an earthquake nerd and you want to know the type. And then we also can see the coordinates. That's what really intrigues me about this API call is the GPS coordinates. And these are actually reversed. So typically you see latitude, longitude, and this is the longitude value and this is the latitude value. So we have to use our brains a little bit on this one. Let me minimize my console. Oh, of course, I cleared that out like a dope. I'm going to type out how you would type out that command. And always, like I said, I print it first to confirm that I'm getting back what I expected to get. So I'm going to print here the word lat, and then I am going to add the JavaScript object for just the first of those earthquakes so I can confirm that I'm actually getting the latitude and the longitude of the earthquake. So here we have earthquakes dot features, and then it's position 0. So you see when we expand this out and I go to features, that features isn't actually a numbered array. So we're going to pick the first, which is 0, inside of that numbered array. And I'm going to say properties. Oh, just kidding. We're going to use geometry, right? So we've got properties, we've got geometry. Geometry. And then inside of geometry, we have to go to coordinates. And then coordinates is another array. So I'm going to set that one equal to the value of 1. Because as I said, this value is what we're looking for our latitude. And then I'm going to do the exact same thing. So I'm even going to copy and paste it to get our longitude. The only thing that's different is that the coordinates array value, sorry, that's a little bit awkwardly squished there. The coordinates array value is going to be equal to 0 rather than being equal to 1. Let's confirm that we got what we expected to get. I'm going to take a little nose at these numbers here to make sure I can go back and verify them. So it looks like the first earthquake in my time span, which may be different than yours, is 122 minus 122.8 longitude. Oh. And then 38.794 latitude. Right? That's right. Yeah, 1 for latitude, 0 for longitude. And I had to go up there and change the longitude because I forgot to do that when I copy pasted. Bonus points if you caught that. So let's go ahead and run this and then check our console to make sure we got the numbers that we expected to get. So negative 122 for longitude and 38.79 for latitude. We're awesome. So far, so good. So now we have this canvas and we have our API call that's running. I want to do something wild and put them on a map. So I went ahead and grabbed this world map from Google. You can go pick whatever world map you want. This is just the one that I liked. And when I load that over into my canvas, it's not going to fit because it's a giant file. So I happen to know how big that file is, and I'm going to do a quick little conversion to make that file fit onto my canvas. That partly requires me to resize my canvas because the aspect ratio, the width versus the height of this image is not square. So I'm going to make my aspect ratio of my sketch equal to the dimensions of my file. So now I have this map of the world that's displaying on my sketch. I happen to pick one that has a transparent background. It was on Wikipedia. So if I wanted to, I could change the size or the color of this background. So I could make it like totally white. And now you'll see when the sketch refreshes, I get a white background on a gray world. So very cool, very simple, very beautiful. I am going to start actually putting that data into some form that we can use to make our generative art piece. And that requires us to take these coordinate geometries and then the magnitude and actually put it into a loop, sort of similar to the one that we made in our other JSON exploration. And the way that we're going to do that is I'm actually going to make the loop here. So for variable I of, and then, oh, sorry, in earthquakes. And then inside of this, we're going to create a variable for our latitude, our longitude, and then our magnitude. And I'm actually going to take this, down to our draw function so that each and every time we loop, we also go ahead and draw a circle for each of those latitudes and longitudes. So we want to make sure that we are looping through this one. So we've got our latitude and longitude. I'm going to make us a variable for each of them. So lat, long, and then we want one for magnitude. So magnitude. See, we're getting complex fast on this one. All right, so we know that our latitude is equal to this value up here, earthquakes, features, and then we're going to look at all of the variables or all of the values inside of the features object, which is why we're looping through them. And then inside of features, we know it lives in geometry, and it's position 1 inside of the coordinates array. So that's how we get our latitude value. Now we want our longitude value, which is the same thing, earthquakes, features, I, geometry, coordinates, and then 0. And then last, we're gonna fill our variable called mag. Oh, mag looks like it has another value, so I'm gonna call it mag with an N. Magnitude, which is equal to earthquakes, features, and then I, because we're looping through it. And then instead of going to geometry inside of our object, we're going to go to properties, like we talked about before, properties, and then just the word mag. Cool. So now we have a variable latitude, longitude, and magnitude that's set equal to the value that we're at inside of our loop. So we're going to create a variable for x and a variable for y. This should feel very familiar. And we are going to set them equal to our latitude and longitude, but with a little bit of math involved. So this is just like a standard calculation for changing things to the size of your canvas for anything latitude and longitude related. The first thing we're going to do is the width of our canvas, which is 716, divided by the number 360. We're basically converting things that go on a circle to a flat surface. And then the next thing we're going to do is multiply that by 180. We want this all to be in parentheses. 180 plus the longitude. And this will give us like a rough approximation of that conversion, but we will also need to scale it to our individual image. So I'll show you how to do that in just a couple of minutes. Let's do the same thing for y. The calculation for y is just slightly different. So we're going to do height divided by 180 multiplied by 90 minus the latitude. Now we should see some dots. Oh, we don't see dots. Does anyone know why we don't see dots? It's because I didn't draw any circles. Silly, silly. Gotta draw circles. You can't just make x and y values. Let's make a circle at value x, value y, and then magnitude as our radius. Now we should have some circles. Cannot read property, coordinates of undefined, line 33. Coordinates, oh, geometry. Now we should have no problem. Awesome. So you see we have some dots over here. They're showing up on our map. You, in real technical terms, should now grab one of these dots that you know the latitude and longitude of. Look that latitude and longitude up on an actual calibrated sketch or a calibrated website to see exactly where it's located, and then shift your sketch accordingly. I, however, happen to know that these dots should be along the coastline in California, stretching from the bottom of that part of the United States and then working their way up to Washington. You can also kind of see that here with Alaska. Like, I'm pretty close, but not quite. And so the easiest way for me to calibrate that is just to go ahead and add a little bit of a value to the longitude and then subtract a little bit of, or we're actually going to subtract from both. So we want to move left and we want to move up. So I'm going to go ahead and take a guess that I want to do like -8 maybe. And then my latitude, it needs to be shifted by less. So I'll do like +3. And then let's see what kind of response we get out of this. Pretty close. If I expand over to the other side of my canvas, I notice that there are some places that should be along coastlines or along lands that maybe aren't. So it makes sense to shift it a little more. This is definitely the artist way to take this on. If you were doing this and you needed it to be technically correct, it would be vital for you to actually calibrate these dots and their locations. But since we're just doing this as like a graphical representation and we're doing it so zoomed out, I feel totally okay with just eyeing this. And I'm gonna subtract a little bit more from the longitude or X direction to make these things line up with the coastlines like I know they ought to. So now we see this looks like pretty intelligible. These are definitely within bounds for something on this level of accuracy in a data visualization. And we are using an API from USGS to actually map out earthquakes from the last 2 weeks onto our canvas. So I could go in and change this date to any set of dates, and I could get a different set of values, and it'll use all of this stuff that we did generally to map those things to our map. And then the last thing I wanted to talk to you about just super briefly is sharing your work. So I am so grateful that you've been here with me on this journey. I'm so glad to have shared this with you. Like, I cannot tell you with more enthusiasm and more excitement, like, thank you for dedicating 4 hours of your life to this. I have learned so much from all of you, both just through the process of making these videos, but also because of those of you who've been coming to office hours. And I want to see what you made. So tag Hackaday in any of your Instagram posts and also tag me. The best way to share this stuff out on Instagram is to use a screen recorder to record your screen and then post that on Instagram. That's something I usually do for most of my P5JS sketches. If you're on a PC, usually that looks like using the Game Center to do a screen recording. If you're on a Mac, you can use QuickTime to do a screen recording. Just go Google it. It's super easy to set up. I definitely have faith that all of you can do it because you made it. So congrats and thank you for sharing this time with me. Swing by office hours if you want a detailed explanation of how to embed your JavaScript into a website or how to screen share or whatever you want to do. But you learned a lot of stuff in such a short period of time, and I'm so glad that I could have been a part of it with you. So thanks for joining me. Bye.